Great. So good morning, everyone, and thanks, Colvin, for the presentation. It's a pleasure to be here at ICLI 2020 in Trondheim. And so, I'm Federico Visi. I'm part of the GEMM cluster. It's a Gesture, Embodiment and Machines in Music Research cluster at the School of Music in Piteå in Sweden. And I co-authored this paper that I'm going to present to you with Atau Tanaka, who's a professor at Goldsmiths, University of London. And I started this work while I was a postdoc there, and I continued it in Sweden. And so, assisted interactive machine learning. So what is it? In a sentence, assisted interactive machine learning is like an interaction design method that we've been developed, and it's based on reinforcement learning. And the purpose of it is to explore the vast space of possible mappings between gesture and sound synthesis, so various possible ways that one can map a live interface to a sound synthesis engine, okay? So you may wonder why we would use such a why we would use reinforcement learning to explore mappings between gesture and sound. So if we look at a little bit of background, in the past decade or so, machine learning has made designing live interfaces a lot more accessible and easier. You may be familiar with the Wakinator, which is the machine learning platform developed by Rebecca Febrings, who's going to be the keynote speaker tomorrow night. And so the great thing about using machine learning for designing interaction is that instead of explicitly program a gesture sound relationship, you just give example to the computer. You train an interaction like a regression model, for example, with a neural network, and then you start playing right away. So there's this new creative relationship between the artist and the computer, okay? And so digital interfaces can be programmed in lots of different ways, no? So there's so many different ways that you can map sensor data to sound synthesis. And so the question is, what if I could collaborate with an AI to explore mappings that I wouldn't normally think of when I train a machine learning model, no? And so this is the motivation behind this method of ours. Okay, so this is the typical interactive machine learning situation where you've got on one side control gestures, such as that are tracked by some motion tracking device. Here I've got my sensor armband. So you extract features, you send them to some machine learning algorithms and pair them with synthesis parameters, and then train the model and play with it. So basically you show how the gesture and sound are related by using machine learning. And so for assisted interactive machine learning, I was inspired by the work that lots of computer musicians have done with artificial agents over the years. There are quite a few examples on the paper, but I'll mention just a couple here. For example, there's this work from the early 2000s by Palle Dahlstedt. He used genetic algorithms to program to generate presets, basically for a synthesizer. In his case, that was I think he was using a Nord modular, if I remember right. And the genetic algorithms were generating presets for him to listen to try, and then he chose the ones he liked, and for survival of the fittest, the one he chose survived the generation. Then they mated and mutated and generated children that's kind of sounded a bit like their parents, but not quite. And so he repeated this procedure until he found some sounds that he found interesting. So I chose that to report that quote from his paper, because it's interesting here to see that there's like both surprise and dealing with complexity, and also kind of retaining a certain sense of control of what you're doing. Things are not random. There's some sort of collaboration between the musician in this case and the algorithm, you know? And similarly, like genetic algorithms have been used by automatically program synthesizer, like in the picture there, like inside that wooden box, there's a Raspberry Pi and a touch screen, and they're plugged to a desktop version of like a Yamaha DX7, which is a very popular synthesizer from the 80s, notoriously difficult to program, like 100 plus sound parameters, menu diving, so people were just using the presets all the time because it was very difficult to program. And so there instead they used genetic algorithms to, it's actually a collaboration between a collective in Britain, which is called Foam, I think, and Aphex Twin. And there, like, they give a target sound to the Pi. It analyzes the sound, and it tries to send parameters to the DX7 that sound like the input sound. And the interesting thing is that it never quite sounds like the input sound. And then, with using genetic algorithms, they try to improve the preset until something sounds interesting to the person listening to it. And so I think, like, again, this is like a sort of co-exploration of complexity in sound synthesis, no? And I think these examples are particularly relevant for the themes of the conference, because we're talking about like artificial intelligence, artistic intelligence, and extending established practices through algorithmic intelligence. And so it's interesting to look at how, for example, machine learning can contribute to established practices instead of replacing them. And so here comes reinforcement learning for gesture to sound mapping. No, so like a quick, very quick introduction to reinforcement learning. So this is like a schematization that I've taken off of Wikipedia, no? And it's like the basic idea behind reinforcement learning. So you have an artificial agent there, like the little robot, which is basically an algorithm that performs an action on an environment. And then we've got an interpreter that observes the action that this algorithm has performed and gives a feedback to the artificial agent. So whether the feedback will be positive or negative will depend on how the action was performed. So depending on how the action was, the interpreter will give a positive or negative feedback, or a reward or a punishment. And the job of the agent is to maximize the reward, so to do things that the interpreter likes, and so it'll try to adjust its actions according to the feedback it gets. Okay. This idea can be also applied for automatic programming of synthesizer for sound synthesis. This has been done by Hugo Scurto and his colleagues, and he published last year a very interesting paper about applying these ideas to the automated programming of VST synthesizers, of software synthesizers, where he had a reinforcement learning algorithm that proposed a few presets on a VST there, and then like people were listening to what came out of the synthesizers and were giving feedback to the artificial agent whether or not they liked the sound, of they wanted more like that or less, and so there was like this co-exploration of the sound space that was defined by the sound parameters. And so if we go back to like our interactive machine learning model, where we show the computer how we want to map gestures to sound, Here now we can add the artificial agent to the picture, no? And instead of actually thinking or like instead of showing the computer like a gesture that I want to pair with a sound and use machine learning to train a model and perform, I could have the agent that actually gives me some mappings already without me having to provide examples. I play with the mappings and I give feedback to the agent to see if I can get, you know, a new mapping that I wasn't thinking about that I actually like playing with. You know? And so this is like more or less the ideas behind this method that we call assisted interactive machine learning. So like to combine interactive machine learning with artificial agent exploration. And typical workflow works like this. You have like your own synthesizer, you program a few presets and store them. And then like you ask the artificial agent to explore the gesture feature space and give some motion features to you to pair with synthesis parameters. Then by pairing synthesis parameters and motion features, you train a neural network, and there you go. You've got a mapping to play with. You play a little bit with it, and then you can give feedback to the artificial agents in step 4 there, whether you like the mapping or not. Also, there's a third kind of feedback, which is explore. So basically, that means try something completely different. Just go away from the particular area of the feature space you're in. And I explain that further in the paper if you want to check it out. And so, and then, yeah, if you liked that mapping, you can store it and save it and then use it for performance later. No? We use this method for with different synthesizers. Like for a user study that is described on the paper, we use that with a simple like sample manipulation synthesizer. And but also we use it with like corpus-based concatenative synthesis, which is a synthesis method that basically takes like large databases of audio files, chops them into little pieces, analyze the audio features of them, and then map them on a feature space. So like imagine those points, each one being like a small fragment of sound, and they're ordered by, for example, I don't know, spectral centroid, loudness, and pitch, for example. And so yeah, then what I did was to apply self-organizing maps to organize a complex audio corpus onto a feature space in a way that it's a bit more like organized. Yeah. And so this is like a good candidate for the use with assisted interactive machine learning, because there's a big sound space to explore. Okay. So if there's time, actually, I think I'll show you a video, so I can, instead of doing a live demo, perhaps that's wiser, so there's more time for questioning. Okay. So this is a preview of actually a performance that will be presented tomorrow night. So here, as an audio corpus, I basically used lots of recordings I had on my mobile phone from the past 1 or 2 years, like audio journals, audio from videos, and audio messages I received from a variety of people, and built like that sound space with that material. And then I used assisted interactive machine learning, this interaction with an artificial agent, to explore those sonic memories through body movement.
Yes.
So I'm very much interested in looking at what happens in actual artistic practice. So like I see these ideas like this method, but also other methods of using algorithms or machine learning in artistic practice is something creatively useful. You know? So something that is able to perhaps surprise you and help breaking creative deadlocks. So the whole idea behind that piece comes from working on this, interaction design method ideas. And so what's important here for me is that like I see these technologies as something that is helpful and inspiring and does not substitute people's creativity. And there's like one challenge is to look at how these ideas can interact with established practices like programming a synthesizer using a synthesizer from the 80s that is quite dumb in terms of how it's supposed to be programmed, or dumb maybe is not the right word. It's quite like maybe difficult. It requires a little bit of practice, you know? And so like one of the motivation behind working with this interaction paradigm is like to support exploration of complexity. So we've got a whole lot of sound synthesis possibilities. We produce like a whole lot of recordings without even thinking about it when we send like an audio message to a person. And how about using algorithms to explore this like plethora of sounds that we have at the tip of our fingers? No? And also another thing that I find interesting is that perhaps by co-exploring how a synthesizer works using an AI, I can actually learn a bit more about how that synthesizer works. So there's like learning through co-exploring. It's a bit like, try to break things together with a robot to see what's inside, no? And not only you learn about the synthesizer, but also you learn about, AI and machine learning that is, like, if you read the news, there's a lot of anxiety about these things, how they're going to change your lives and so on and so forth. And so perhaps by using it actively to build something, then you learn something about it. Yeah? So, tusen tack.